Okay, so we're going to look at these review problems. So let's get started. So this first one, it gives us the x-intercept and the y-intercept. So these are really easy if you realize how to do this. You just plot those and connect them. Do not make a point with those intercepts. So do not make a single point. Let's change color here. Do not make a single point like this. -1, 2. And try to do something with that. No, do not do that when you're given these intercepts. Okay? Instead, what you want to do is use each of those separately. So the x-intercept is -1. That is on the x-axis, you go to -1 and plot that point. Okay? On the y-axis, go to 2 because the y-intercept is 2. So go x-axis -1, y-axis you go to 2. It's right there, and that's your points, and that's what you connect with a straight line. And mine isn't very straight, but you get the idea. Okay, let's look at the next one. I think we'll go with purple here. We have school spirit. So we're plotting this. This time we have an equation, and this is in slope-intercept form. Have to be able to recognize when they are in that form. Because when they are, you can plot them using the y-intercept, okay, which is that, and the slope, which is right there. So you just go to that y-intercept, which is 5. On the y-axis, make a point on that y-intercept, and then the slope is -5. And I'll write this one out over here this time. The slope being -5 means the rise over run is -5/1. Okay, so you start at the point we've already made, and you just go down 5/1. So down 1, 2, 3, 4, 5, and over 1 puts us right there. That's our other point. Connect those points. Not very good at drawing on this at all. We'll try to do a little bit better. Okay, make the line. You get the idea, even though mine is not very good. Okay, so the next one, that's also in slope-intercept form. Okay, so we have our intercept here, and we have the slope here, 5/4. So our intercept is -2, so we go to -2 on the y-axis, and then the rise over run this time is 5/4. So 1, 2, 3, 4, 5 up, over 1, 2, 3, 4 from there, and that's it. And now we make that line. Okay, so that's that one. Okay, just wanted to check something. Okay, yep, got those. So now let's go over to this one. So we've got to graph this. It's not in slope-intercept form, right? We want it to be in slope-intercept form. We want it to be in this form. Whoops. Y equals mx plus b. That's a mess. So we just have to get y by itself on the left, which we do by subtracting x from both sides. they're subtracting 2x. So we subtract 2x from the left, we subtract 2x from the right. And on the left, we now just have y. And on the right, we have negative 2x plus 1. That is now in slope-intercept form. That is the intercept. Negative 2 is the slope. And so we go to the y-intercept, which is right there, 1 on the y-axis. Slope is negative 2 this time, so rise over run is negative 2 over 1, down 2 over 1. So down 1, 2 over 1. Okay, and that is, now we just make that line. Okay. Okay, let's look at the next one. Now we are graphing inequalities. So this is greater than. So this is one of those where we're going to shade a big section of the graph. We are going to first make that boundary line and then shade one side or the other. And we have to decide, do we make the boundary line dashed or solid? So this one's going to be dashed because it's not greater than or equal, it's just greater than. So we make the boundary line. We see this is in slope-intercept form because we have mx, that's our m, and we could write plus 0, right? We don't have to, but I'll go ahead and write it. And whether you write it down or not, 0 is your y-intercept in this one. So there's the point 0, and rise over run this time is negative 3 over 1 because the slope, we can always write it as a fraction, right? Negative 3 over 1. And so we go down 3, 1, 2, 3 over 1. There's our point. And we just have to make a dashed line connecting those because, again, this is not greater than or equal, so we don't make the solid line, we make the dashed line. Okay, and now we just have to decide which side to shade, and we shade above because it's greater than. So shade above. Why did my shading go away? Guess we'll put it on again. And that's it. Okay, so let's look at the next few. And they're being kind to us right now. We have another one that's in slope-intercept form already, right? So we have our slope here of 1/5. We have our intercept of 3. So we go to 3. We're plotting the boundary line, remember here. Or we're going to graph the boundary line first. Our rise over run is 1 over 5. So up 1 over 5. Up 1 over 1, 2, 3, 4, 5. Right there. It's greater than, it's not greater than or equal, so it's a dashed line also. That is a really sloppy dashed line. I'll try to do a little bit better. Okay, here we go. One more try. Bad or good? This is going to be it. Okay, could be worse. So there's a dashed line, and it's greater than, so we shade above. Okay, look, the next one. This one's not in standard form. We need to put it in standard form. So we're going to subtract x from both sides first. Not like that, though. Whoops. Okay. So we get negative 2y is the only thing on the left that's greater than or equal to negative x minus 6. And now we divide both sides by negative 2y. By negative 2. And we're dividing by a negative here. So we're going to think about that symbol. So we divide each of these terms by negative 2. Okay. And on the left, well, first of all, what is the symbol? It was greater than or equal, but we divided by a negative 2. So now it's less than or equal. Have to turn it around. We have y less than or equal to, this is positive now, x over 2, but we'll write that as 1/2 x. And then minus a negative over here makes it positive, and it's positive 3. So now it's in slope-intercept form. We have the slope of 1/2. We have the intercept of 3. We can now plot this line, our boundary line, and go to the y-intercept of 3. Our slope is 1/2, so that's rise over run is 1 over 2. Up 1 over 2, right there. And it's a dashed, no, this one's a solid line because it's greater than or equal. Okay, so we make it a solid line. Okay, and we shade. Be careful here. Don't look up at your original inequality to decide which side to shade, because that one's not in slope-intercept form. So it doesn't tell you anything just by looking at it as far as which side to shade. Instead, look at the one that's in slope-intercept form. That's down here. Okay? That's the one. And it's less than or equal, so we shade below. Okay, so that's it. Okay, now we're to the absolute value equations. You can do these a couple of ways. Mostly we focused on finding the vertex and going from there. So let's look at that first. So the vertex of this first one is, what's the x-coordinate of the vertex? Well, we could write the general form when a is 1. When a equals 1, you don't have to write it because a is that number that's multiplied by the absolute value. So if it's 1, you don't have to write it. So don't worry about the a for right now. The general form when a is 1, though, looks like this. Okay, so we want to know that h. Oh, and the vertex, sorry, I need to write that down too. The vertex is h comma k. Okay, when we're in that general form. So we want to look, what is h in ours? Okay, h is the number right there because ours matches the general form exactly. It's x minus something. The general form is x minus something. Okay, and that something that's subtracted, that is your h. Okay, which is the first coordinate of your vertex. In this case, it's 1. So just remember, when you have a minus sign in there, you just take the number exactly positive 1, because that's what's subtracted. So This one's 1, and the k is a little easier. That's what's on the outside. It's -4. That's it. Okay, so now we plot that. 1, -4. Oh, wrong point. Sorry. 1, -4 is right here. And then we just go up and over to the right to here, up and over again, and just keep going that way to the right. And we also go up and over to the left. Okay, up and over as many points as we want, and we stay on that line there. Draw that when that's the V shape. That is the graph of this this equation. Okay, so you can also do them like this, and I'll just do this for this one. You can make a table of X and Y. Just make sure you include this point at the bottom, and the easy way to make sure you include that is that you use one of your values of X over here has to be such that inside the absolute value bars you get 0. And then you use a value less than that and a value greater, and you can graph it that way. So what value of X gives us 0 inside the bars? Okay, well, we're going to subtract 1 from it inside the bars. So if X is 1, 1 minus 1 would be 0. So we have to use X of 1, but we'll write it, we have to use the value 1. We'll write it here, and then we want something less than that. So that's why I wrote it in the middle. So we'd have room up here above that 1 I just wrote, to put 0, okay, a number that's less than 1. And we put a number greater than 1, which is 2. So we could plot these 3, and you do it with a different color. Let's see, how do we get our colors? So I'll stay with purple though while I calculate the values. We put in a 0 for X. That would leave inside the bar 0 minus 1, and that's -1. The absolute value of that is 1. Minus 4, though, is -3. 1 minus 4 is -3. So let's put 1 in there. 1 minus 1 is 0. Absolute value, that's 0. Minus 4 is -4. And we put 2 in there. We'd have 2 minus 1 inside the bars. That's 1. And the absolute value of 1 is 1. Minus 4 is -3. So we have those points. We'll graph them. 0, -3. Looks like right here. Right where it was. That's good. We expect this to be the same, right? 1, -4 gives us this one. And then 2, 3. And that's all we're doing here. We're using each row of this as an X and a Y to plot a point, right? So the last one is X is 2, Y is -3. X2, Y -3, that's right here. So we plotted those 3 points, and when we connected them, we would get that, and it's exactly the same thing we had when we did it the other way. Okay? So you can do them either way. Finding the vertex and going from there is faster if you're sure you're doing it right. So look at this one. Okay, what is the vertex of this one? Well, what is subtracted from X inside those bars? It's just 0. We could write it down that way. Oh, let's go back to purple. Let me take a look at that other one. Yeah. Okay, so we could rewrite this as y y equals X minus 0. Or you could just know that the thing that's in there that's subtracted from it is 0. Okay, so we get our x-coordinate of our vertex from that. So for this one, we'll write it over here. Vertex is 0. That's our x-coordinate. Our y-coordinate comes from this over here, and that is 4. So that's our vertex right there. 0, 4 is the point. We go over 1, up 1, and the other side over 1, up 1. That's actually enough. We could do a couple more. Draw those lines. And that's it. Okay? So just have one more. Whoop, let's see here. Okay, so this one, we need to get our vertex. And we're looking for what is subtracted inside there. That's going to be our x-coordinate. And this doesn't have to be confusing. There's nothing subtracted. Instead, it's added. But you can always write that. You can always write addition as subtraction. You could write that as x minus -2. Okay, so -2 is the x-coordinate of our vertex. If we write it as subtraction, it's -2. And because the general form has a minus sign in it, if you don't have a minus sign in yours, well, then you just have to make it, you use the negative of that instead. So -2, and we could write the +0 out here. The y-coordinate's 0. Let's plot that. -2, and then that's our vertex. We go both sides, up and over. I'll make that better. I can't get it to erase. There we go. Okay, so that's it. Again, you can plot the points instead with this type of deal if you want to. You can do it either way. And don't let the vertex thing, don't make it harder than it is. If you have a plus in there, you just know that you're going to use the negative. Okay, but if it's minus in there, it won't be. You'll just take the actual number that's subtracted, and that will go in as the x-coordinate of your vertex. Okay, so that's all the problems. Hope that helped, and see you later.